I am Anil Kumar. Welcome to my series on trigonometric equations. We have 4 questions here based on compound angle formula. We'll try to see how to solve these equations. You can always pause the video, answer the questions, and then look into my suggestions. The compound angle formulas which I am going to use are the following. The first one is sine A plus B, which is written as equal to sine A cos B plus cos A sine B. The other one will be cos A plus B, which is cos A cos B minus sine A sine B. Now it is important to note that you write these formulas with negative sign also. So when I do sine A minus B, think as if B is minus. Then cos B is even, that remains positive. Sine B is odd function, so that becomes negative. You get the logic, right? So if I make here negative, sine being an odd function, sine minus b is going to be minus of sine b, so that minus will get converted to plus. So basically, the 4 formulas can be written as 2 as I've shown here, and there is a logic which you should understand, and that is very simple. And this is that sine of minus b is equal to minus sine b, and cos of minus b is cos b. Since cos is an even function, sine is an odd function, right? That's a small review. And now we are going to take these questions one by one. Also, look into the domain. We want to solve the equations when x is between 0 to 360. Now remember that we could have 2 solutions for each question. So for that, all are positive here, right, in quadrant 1. Sine is positive in quadrant 2, tan is positive in quadrant 3, and cosine is positive in quadrant 4. So remember this also. These are your quadrants 1, 2, 3, and 4. So that will help you to understand which 2 are the right solutions. Correct? And we'll also look into the acute angle concept. So first we'll find the acute angle and then the other angles. So let's begin with the very first question, which is sin x cos 10 plus cos x sin 10 equals to square root of 3 over 2 with a negative sign. Now applying the formula, which is compound angle formula, which once again let me write down here, we have sin A cos B plus cos A sin B is given to us, which is basically equal to sin A plus B, right? So we can actually write down the given question, which is, let me rewrite this, sin x cos 10 degrees plus cos x sin 10 degrees is negative of square root 3 over 2. Left side is equal to sine x plus 10 degrees. Clear? Now, when is sine negative square root 3 over 2? That is what you have to figure out. So we know negative sign means we are looking into 2 quadrants which are 3 and 4, and that you get from the rule that sine is all are positive in quadrant 1, right? Sine in quadrant 2, tan in 3, and cosine in 4. Now we are looking for negative answer, right? So we are looking for a negative value. That means that we are looking for a solution in quadrant 3 or in quadrant 4. That is what we're looking for. Since we know that x is between 0 degrees to 360 degrees, as was given in the question, correct? Now, we need to find the acute angle alpha. That is the angle which we should find, and that should help us to get the solution. Now, square root 3 over 2, as you may recall, is a direct result from a special triangle. So I hope you remember that. So if I have this as 60 degrees and the other angle as 30 degrees with a right triangle, special triangle, the sides are as shown here. You're looking for sine value of minus 3 over 2. That means we're looking for something opposite and hypotenuse, correct? So that is 60 degrees. Perfect. So we know from here that the angle we can write here as, we can write this as sine of alpha is equal to square root 3 over 2. So whenever you want to find the acute angle alpha, it is going to be positive, and that gives you the value of alpha as equal to 60 degrees. Right? So the idea here is to find the value of alpha first. And then we can find possible values, correct? And so now we get two possible values for x plus 10. So these positive values will be, in quadrant 3, it is going to be 180 degrees plus 60 degrees. And in quadrant 4, it is going to be 360 degrees minus 60 degrees. Is this concept clear to you? Perfect, right? So that is what is the key to provide solutions. Now here you can add this up. So we get 240 degrees and this is 300 degrees. That is x plus 10. So the value of x is basically equal to 240 degrees minus 10, which is 230 degrees, or 300 degrees minus 10, which is 290 degrees. Correct? So that is how you could actually find the solution of this particular question. I hope the steps are absolutely clear. So let me write down the answer here. So the answer here is x is equal to 230 degrees or 290 degrees. So I hope you find it simple, right? It's kind of tricky since we need to find the acute angle alpha first and then get our solution. So once again, we use the compound angle formula sine A plus B to find what sine x plus 10 will be. Since it is negative, we are looking for solutions in quadrant 3 and 4. Sine of 60 degrees is square root 3 over 2, as you can see from here. And therefore, the alpha is 60 for us. When you add 60 to 180, that is the solution in quadrant 3, we get what? 6 plus 8 is 14, 240. Take away 6 from 6 is 0, 300 degrees. Correct? Now, x plus 10 is equal to both these answers. What is x? We have to take away 10 and write down our answers. So I hope now all the steps are clear so you can solve rest of the questions. Here is question number 2, which is on the same logic. So I'd like you to pause the video and answer this question. Remember, the value of x, which we're looking for, is between 0 degrees to 360 degrees. Let's follow the steps. Sine x cos 10 minus cos x sine 10. Let's rewrite. So the question is sine x cos 10 degrees minus cos x sine 10 degrees is equal to minus half. Now in this particular case, we are using cos A minus B formula, right? So we are using sine A minus B. So we get x minus 10 degrees is equal to minus half. And once again, let's look into the quadrants. We are looking for two solutions, both when sign is negative, and that is where the solutions should lie. So this is all are positive, sine, tan, and cosine. We are now looking for the acute angle alpha, right? We want this angle alpha, the acute angle. So we are saying let sine alpha be equal to half. Now alpha is acute angle, it is going to be always positive, correct? So once again, let's look into our special triangle, and the special triangle is 30, 60, 90. So we have this special triangle here, and that is 30 degrees. That gives you the opposite side of 1 and the hypotenuse of 2. So that is the right triangle. So we know that alpha is equal to 30 degrees. And that gives you two solutions. One, 180 plus 30, the other one, 360 minus 30. So we can write x minus 10 is equal to 180 plus 30 degrees, or you can say x minus 10 is equals to 360 minus 30, right? So 360 minus 30 degrees. So all are in degrees. So we get x as equal to, so you can take add 10 also to this. Okay, let's write this. Okay, so x is equals to 360 degrees minus 30 plus 10, and that gives you the value of x as, when you add 40 to it, so for 220 degrees, and here we get 340 degrees, correct? 330 plus 10, 340 degrees. So we have our answer. Both the answers are within our limits, which is 220 degrees and 340 degrees is value of x. Is that clear to you? So that is how we are going to answer this question. Now let's take up the next question, question number 3, which is again a similar question but based on cosine. So the question now here is cos of x times cos of 20 degrees minus sine of x sine of 20 degrees is equal to 0.23. Now 0.23 means we have to use calculator, right? So we need to use calculator in this case to find what acute angle will give us that particular angle. And here we can use the compound angle formula, which is cos A plus B. So cos x plus 20 degrees is equal to 0.23. Now, let's find the angle which will give us the required result. Cosine positive means we are looking for two solutions which are either in quadrant 1 or in quadrant 4. Since we know that all are positive in quadrant 1, sine, tan, and cosine, so those are the values which we are looking for. So one of these angles is definitely the acute angle alpha. The other one is 360 minus alpha. So we'll find what alpha is, right? So we can say that we'll work for sine alpha equals to 0.23, sorry, cos alpha, not sine, okay? So it is cosine function. So we look for cos alpha equals to 0.23. That is to say alpha is cos inverse of 0.23. Let's use the calculator. The mode should be in degrees, and we'll do shift cos inverse of 0.23. And that gives us a value of alpha as 76.7. So that gives us alpha as equal to 76.7 degrees. So that is the angle, acute angle, which we have got. Now we'll continue with our solution. That means the value of x plus 20 could be either equal to 76.7 degrees or 360 degrees minus 76.7. Now, if I take away 76.7 from 360, I get 283.3. Correct? So those are the two values for x plus 2. What is the value of x equals to? X will be 76.7 minus 20, which is 56.7 degrees, or x equals to 283.3, take away 20 degrees, which is equal to 263.3 degrees. So we again have two answers here, which are 56.7 degrees and 263.3 degrees. So that is how we are going to answer this particular question. Correct? So we have done one type of solutions, and that is for the questions 1, 2, and 3. So what you really found in these questions is that we converted them to our compound angle formulas into one particular ratio and find two solutions based on which quadrant it will fall. Now, question number 4 is slightly tricky. I would like you to pause the video, answer this particular question, and then look into my suggestions. Well, we are now given the compound angle. So we are saying that sine of x plus 45 degrees is square root of 2 times cosine x. We'll expand this time. So we can write this as sine x cos of 45 degrees plus cos x sine of 45 degrees is equal to square root of 2 cos x. Well, you have this special triangle once again. 45 degrees triangle is the one in which both the legs are equal and the hypotenuse is square root 2. So the value for sine and cosine is 1 over square root 2, or you could also write this as square root 2 over 2, right? Okay, so we can write this as sine x times 1 over square root 2 plus cos x times 1 over square root 2 equals to square root 2 cos x. Multiplying by square root 2, we get sin x plus cos x equals to 2 cos x, right? So we multiplied each term by square root 2. So we'll multiply by square root 2, both sides. Now we can simplify. So what do we get? We get sin x equals to 2 cos x minus cos x, and that gives you sin x equals to cos x. Now dividing, we get sin x over cos x equals to 1, and that gives you tan x equals to 1, right? So tan x equals to 1 means that within the quadrant, we are now looking for two solutions. One of them will be in quadrant 1, the other one in quadrant 3, right? So we have these two solutions. When is tan x equals to 1? It is 1 for 45 degrees, right? So this acute angle is 45 degrees, and the other one is 180 plus 45. And so we can write down our answer as x equals to 45 degrees and 45 degrees plus 180 degrees. Since the period for tan is 180, right? So which is equal to 225. So which is 225. Okay, so let's rewrite the answer here. The answer for this particular question is that x is equal to 45 degrees. So the solution here is x is equals to 45 degrees and x is equal to 225 degrees. Is that clear to you? So that is how we are going to solve this particular question. I hope the concept is absolutely clear. Let's have a good look at this set of questions. The first three we actually expanded, which were already expanded. We clubbed it together using the compound angle. And in the last question, we had kind of reverse approach. So we, in this case, expanded and simplified. Correct? That is how we solved it. And remember, in such cases, especially when the domain is given to you between 0 to 360 degrees, you expect two answers, as we did in this particular case. I hope that makes sense. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.